Welcome back, summer mathematicians. I want to take a look at today. We've got something very simple here. It is multiplying and dividing mixed numbers. So I know they are separate operations, but they share a first step, and I wanted to do a quick overview. So let's take a look at our objective. I will convert mixed numbers before multiplying and dividing. Sounds simple enough. Read it with me. I will convert mixed numbers before multiplying and dividing. So let's talk about conversion. This is where we go from a mixed number, let's pick a small one like 1.5. If we write it as an improper fraction, we are converting it. So 2 times 1 is 2, plus 1 is 3. An improper fraction that's equivalent would be 3/2. 1 1/2 is the same as 3/2 because we're using the denominator of 2. So let's see, 3/2. It's like saying half plus half plus half. We know 2/2 make a whole, so that would be our 1 whole, and this is our remainder. But if we just add up those numerators, that's where we end up with 3. All right, so let's take a look at a sample mixed number. This sample mixed number here, we've got 2 1/3, and since the denominator is 3, the denominator is always key. We could simply do this as an addition problem. We could say, well, since we're using 2 wholes, 1 whole is 3/3, plus another whole 3/3, plus our remainder of 1/3 gets us to, and I messed up my first time around, 7/3. So 2 1/3 is the same as 7/3. A shortcut to this that is not using an additive process is our conversion. And when we convert, we want to go clockwise, just like the minute and hour hand on a clock, we're going to go in this direction. So we start at the denominator and we multiply, then add. 3 times 2 plus 1. If you want to write this as an expression, you can write it left to right, 2 times 3 or 3 times 2. Either order is fine. But we're going to do that first and then add. And we end up keeping that denominator. Now, we did touch on this earlier in the course. And for those of you that need to see a little bit clearer on the matter, I came up with this. We've got our whole number times our denominator, or vice versa, plus our numerator, keep the denominator. So this is a written out diagram of all the parts involved. All right, so that's our goal of looking at conversions. So let's look at a sample problem now. 2 1/3, so the same mixed number we were playing with, divided by 1/2. Once we convert the mixed number, all the other steps are the same. So we've already converted it. We know that 2 1/3 is the same as 7/3. So we need to dig back into our memory. Keep, change, flip. So we hold on to the dividend. We change to multiplication. And then we get our reciprocal, 2/1. We just flip that second fraction. And we end up with another improper fraction, 14/3. 7 times 2 is 14, 3 times 1 is 3. Now we divide it down. 14 divided by 3. How many 3's fit in there evenly? Well, sure, that's 4, because 4 times 3 is 12, and I'll have a remainder. The remainder becomes my numerator, and I keep my denominator. Now remember, what's happening is, visually, we have 2 whole pieces, and we have a third of a piece. One's a little bit smaller, but since we're using thirds here, we can make all 2's a third. So what we're ending up doing is we're saying these are all the pieces we have, and let me go through and highlight. So our 2, we've got 2 holes, and we've got 1/3 over here. What we're saying is, when we divide by half, we're dividing all the pieces by half. So, cut it, cut it, cut it, cut it, cut it, cut it, cut it. So we end up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 thirds. So this is visually what's happening. So we're saying we're dividing it by half, we're creating twice as many pieces. So our 7 thirds turns into 14 thirds. And if we divide it down, that's how we end up with 4 2/3. But visually, this is what's happening. All right, let's take a look. That was division. That was division. Let's take a look at multiplication. And multiplication has a couple of options. So multiplication, the first option I'm going to show you is breaking it apart. So our 2 and 1/3, we can break that into 2 and a third, and say 2 times a half and 1/3 times a half. So let's look at 2 times a half. 2 times a half is the same as, I'll switch colors here. Remember, every time we run into a whole number, we need to rewrite it 2 over 1 times 1 over 2 equals 2 times 1 is 2. 1 times 2 is 2, which is the same as 1. So let's think about that. If you have 2 of the item and you're multiplying by half, you're getting half of. So we're saying I have 2 pieces, and I want half of them. That's how many you're going to get. So when we multiply by a half, we're just taking half of the first number. So we end up with 1. All right? We'll hold on to that. Hold on to that 1. Next, we can do a third times a half. This one's really easy. 1 times 1 is 1. 3 times 2 is 6. And we can put those two together, our 1 and our 6. Let's bring them together. We'd have 1 and 1/6. Also, this could be written as 6 times 1 plus 1, 7/6. Either of these two answers would be correct. So this is one option. This is your break it apart. Some of you, this might be the way you want to do it. Break it into smaller pieces, like you're eating a large steak. You want to cut up the pieces so you don't choke on it. This would be the mathematic version of that. Let's look at converting. Converting, for those of you that like to skip steps, let's take a look. We're using the same whole number as earlier, so we can go through those steps. With 3 times 2 plus 1, we get 7/3. And then we multiply. 7 times 1 is 7. 3 times 2 is 6. And in case you weren't paying attention, that is the same answer. So you can break the mixed number apart, do two separate problems, and then bring it back together. Or you can simply convert, multiply, end up with an improper, and if we divide it down, how many 6's fit into 7? 1. What's the remainder? 1. Keep the denominator, 6. So we have the same answers. Just one extra step will help you decode these mixed numbers and be successful when multiplying and dividing. All right, guys. Good luck today.